So what is hard? Third one, print the following message using only one printf. Notice that we have a new line, right? After C. So we can use printf. In this way. Using this one. Like this. This is the control symbol to let the string starting from a new line here. Okay? Okay, we'll continue. Identify whether the following identifiers are valid or not. Is valid or not? The first one, Mag9. Test reads is sharp ULT. Underline with average. FPTR. So, valid or not? If you want to identify following actors valid or not, you have to understand the principle of defining variables in C programming. Variables in C programming can just only be composed of numeral, letters, underline. But the first one should only be letters. This one is true, valid. And this one, special symbol cannot be used that. This one is also okay, but this one, we cannot use letters as the first one, as the first letter of variable. Okay? This is not valid, invalid, valid, invalid. And it's also case sensitive. So these two variables are different. It's case sensitive. Uppercase is different from lowercase. Identify and correct errors in the programs given below. So please do it. Yes, this one. Miss semicolon. And where are the errors remaining?
We need to add inverse to the float.
So please do it on your laptop and give me the right answer.
Okay, teacher.
How many errors in this code, in this example? Sorry? Here? Where are the two? Speak louder. N. N. Write on the blackboard.
There are 4 errors, teacher.
On this blackboard with pen. Return. Return 0. And then? Just only one? Only one error? Okay, go back. The guys in the
There's too many.
classroom says that
There's too many errors,
we
teacher.
miss this one.
Yes.
And 0. Because we have
We have
written up
8
here.
many. Yes.
Int with this one. If you don't want to add this element here, you can replace voids with voids.
Or we can type int main void.
Yes, and then
No.
where are the remaining errors?
Hmm. I did it.
Where are the remaining errors? Find that. Okay, if you don't know why you compile it,
Teach.
then
We need to add
compiler,
inverse to the float.
where? Float,
We need to add inverse to float in the 1, 2, 3, 4 in the fourth line
was 9,
next to number. Wait,
this one,
here we should write no inverse. No, here.
where is that?
Can I share my screen?
Yes,
Can you pause yours? Liz.
there are 4 errors.
No, it's
Okay, tell me where are the 4 errors?
تشوف screen.
Can you make your screen bigger? Okay, firstly, let the code on your laptop as the code as mine. Then compile it first. And don't try to fix that.
Okay. See it. Look. What is it? This is the code without with errors. So first we need to correct this. We need to
Yeah, this one.
this is the first. Then we need to add inverse.
Yes. So tell me the reason.
Because we call it here.
We use it here, but we don't declare it.
We don't, yeah, we declare it here, but we don't.
Yes, so
And
if you
again,
want to
we need
use it,
return.
you have to declare it first.
Yes. And then we need to add return 0 because here we don't use the void. But
Yes,
if we use void, we don't need to type return 0.
yeah.
That's it, teacher.
So just only 3?
Yeah, I think this is all.
Okay, but who tell me there are 4 errors?
The fourth error. Yeah, we need to add here. We need to add inverse here.
Inverse here?
We need to add, yeah, as well, and add the printf function.
Okay, good. Okay, stop.
Okay,
Don't use percentage E here.
Stop now.
It's percentage
okay,
F.
I'll stop, teacher. وش نضرب عليه؟
Stop sharing.
Okay,
You can leave now. Stop sharing.
maybe stop there.
Stop sharing.
Okay, teacher. Wait a second.
Can you see my screen? Can you? Okay.
Sir, I have done this, sir.
We have already inverse here. Okay. And this guy, tell me that here, inverse means if you want to use inverse, you have to declare it. Okay? Declaration. Declare. Declare that. This is the first one. Then miss semicolon. And then we miss here, ampersand. Right? Easy to miss. Because if you want to use scanf, we have to use ampersand operator. Okay? So you don't notice that, right? Isn't it? It's error, isn't it? Here. You miss ampersand. And here, this one, you'd better use F. Because number is a float type. Okay? And return 0. Return 0. So we have 1, 2, 3, 4, 5. 5 errors in this example. Okay? Can you notice that? 5 errors. And this one, ampersand, don't miss that. I've said it again. It's easy to miss that. Ampersand. Ampersand. The address of number, you should know. Then you can input numbers to input values to number. Okay, last one. The last one. Go on. This example is to add 2 values. and then print the results on the screen. common errors in this example. Finish? Okay. I noticed that some guy give the right answer to the group. See, I have to say it again. This one. What is that? NUM1? There's space between them. So if there is a space between them, we take these two separate. So you have to delete the space between them. This one. Like this, right? And also, someone said that we miss some. Do we really need some? Because here, sum is not variable, okay? Because we get value and directly print it. We don't assign the value to the sum. If I and then assign the result to the sum, here, sum, but here is different from sum here, okay? Sum here is just like a string. It's not actually a variable, but here sum is variable, okay? So if I do things like this, then I have to define sum here, okay? However, I don't do things like this. So I don't need some variable, right? Then here, there's space between N and F here. Num1, num2 are integral, so we'd better use D for integral format, okay? And this one, percent D is the placeholder for the value of num1 adding with num2. Right? And lastly, we have one left pair, right left pair. These two are pair, and this is, we don't need this one because we have said that we have to make this as pair, okay? So the right answer is like this. Okay? And also, we miss this one. Double quotes. This one. This is string. Just like this. Right? If you want to print the string on the screen, you have make them as string. And encode them as double quotes. Enclose them. Enclose this part with double quotes. Okay? Double quotes. Okay, this is the second chapter. Yes, ampersand with num1 and num2. Okay, scan cut off. You finish the scanning? Hello?
Yes, sir.
I will close this one. Can you scan the code again? You finish the scanning? Okay.
So can you break back code? I didn't scan it.
So I have given you enough time to scan the codes. Okay. We go to the chapter 3, control structure.
Teach.
For the last few chapters, we have know the basic knowledge about C programming, and in the previous chapters, we have talked about that we have three kind of structures in the C programming. The first one is sequential. Execute the statements step by step, okay? Sequential. And the first structure is simple, but not enough, because we have to deal with complex problems in reality. So we have another two control structure. The second one, branch, like this. Here we set a condition here, condition. And which branch we have to execute depends on the condition, true or false. If the condition is true, for example, then we execute this part. Execute. We go to this path, okay? If the condition is false, then we go to this path. So here we have a branch here. We call this option. A branch. Branch structure. And then the third one, loop, like this. Or we call repeat. Okay? So in this chapter, we will learn how to use these two option and loop structure. In this chapter, you have to map program to solution, flowchart, then passcode forms, and you have to able to develop program containing selection and loop control structure. Selection also called option. Firstly, we talk about loop, because if you know the meaning of loop, then if is also the same. Here. We have two kinds of loop structure. The first one is while structure, while loop. Here, this is condition. This is false. This is true. So here we began from here. And then we first test the condition. Okay? Test condition first. If this condition is true, then we execute. Execute statements here. Using brackets. Then, after finish that, we go back. Go back to what? Go back to test the condition again, okay? So we call this loop. Go back. Understand? We call this kind of structure loop because we have to go back. Go back to test the condition again. And the condition is changed, okay? The condition is changed. If the condition is not changed, then we go to the loop which cannot be terminated, okay? The condition should be changed. Otherwise you cannot terminate. Change the condition. And then we go on. If still true, then we execute the statements again. Otherwise, we finish. If the condition is false, then we finish. Okay? And we have another structure. So compare their difference. We call this type untier. So compare their difference. Here, for this one, we test condition first, right? For this part, we execute the statement first. So their order is different. So for this one, no matter what the condition is, this one execute first, okay? Execute A first. After that, we condition, we test condition. And then it's the same as that one. If condition is true, we go back and then test condition again. Execute the statement first, still, and then test condition again. When we terminate depends on the condition. Until the condition is false, until P is false, then we finish. Okay? So here, for this one, test condition first. For this one, test condition later. If the condition is when the first time the condition is false, then the following will not be executed, okay? If it is false, then we terminate directly. For this one will be executed at once, okay? If the condition is false, then we finish. But this one will be executed once. So how loops controlled? We can see this picture. This is loop. We have to control it. Otherwise, this code will be executed forever. Okay? Which means that you cannot finish your coding. So condition must be controlled. We have different ways to control condition. Number or counter controlled, or sentinel controlled. Okay, So firstly, we see what's the meaning of contour control. There is flowchart here. Firstly, we begin from here. Begin from here, initialization. Initialize some other variables here, and then we have to initialize contour. Okay? After that, we test count value. Test count value. If the condition is true, then we do some things here. Okay? Otherwise, we directly finish it. Finish this loop. After we do some things here, we must update contour. Update contour, which means that you have to change your condition. And condition here. After you changing the condition, you go back and test the condition again. Okay? If it is still true, then we execute things here. Okay? And then update again. And then go back again until this condition is false, we finish it. Okay, can you understand this flowchart? Okay. So we focus on three important elements for contour controlled loop. The first one is initialization. Initialization. The second one, update. If you don't update, condition will not be changed, okay? Then you will execute the code forever. And the third one, condition test. Needs to update counter first. This is first step. Second step. Third step. And the third step will make impact on second step. Okay? Then we see an example like this. Draw a flowchart for the following problem. Read 5 numbers and show the addition result. So firstly, you should know what is the input and what is output, okay? It's easy. Here, Input is 5 numbers from N1 to N5. Output is the sum of N1 to N5. Like this. Input 2, 3, 4, 5, 6. Output 20. Okay? If we use sequential structure like this, we input N1, input N2, input N3, N4, N5. Right? This is easy. Easy to understand, right? After that, we get value, add them together, and then get value, and then output it. Here we just only 5 numbers. How about if we have 1,000 numbers? We can get value like 5 numbers, right? But it's not very efficient. Here, assuming put example, these numbers. N1, N2, N3, N4, N5. Okay? And then after that, we execute this part, execute this statement, get the sum, and print it. This is not efficient. Because here, there are 5 plus 1, 6 variables, okay? For this example. So this is not very space efficient. Do we have another way to deal with that? Do we have another way to deal with that? Yes, of course. This flowchart doesn't use loop. Hence, we need to use 6 different variables. Okay? It can be executed with only 6 variables, but how if we have 1,000 or 1 million variables? Do we really need so many variables? Of course not. If we use loop structure like this, initialization, and then here, counter is our condition, okay? Because we have 6 numbers here, we count them one by one. If the condition is true, then we input n. Input n. For example, input 2 to n, input 3 to n, and then add them, right? So this kind of behavior repeats. This is repeating behavior for loop structure, okay? If you want to use loop structure, you have to analyze what is your repeating behavior, okay? So here, this part is called. You have to analyze what is your repeating behavior. and then update. Update condition. After you update condition, you can go back to test the condition again. If you don't update this condition, if you don't update, counter will always be 1. Understand? Will always be 1, and 1 is always less than 6. So you cannot go this part. Okay? So your code will execute forever. Will always go this part. Okay? So you have to update your condition and test again. So this example tells us that we can use loop structure to deal with this kind of problem. Okay, let's see what happens inside the computer. For this one, we have initialized counter as 1, sum as 0. And then test this one. This is true, right? Then we execute following this part. Then input n, right? Here, the first one, number 2, input to n. We go on. This one, sum. Sum is 0. N is 2. We get the number 2. So sum will be changed to 2, right? And then we go on. Counter. Counter becomes 1. From 1 to 2, right? We change condition. If we don't change that, you always execute this pass. And then we go back. This is true or false? True or false? It's still true, right? And then we continue. Input n, 3. Right? N becomes 3. N becomes 3, and sum is 2. We add this. Two with 3. So sum becomes 5. Right? Go on. Counter. Here, change. Counter. 3. Right? And this is still true. So we go on. Then becomes 4. We go on, like this, right? Adding sum 5 with 4, we get 9. Sum becomes 9. And counter becomes what? Counter becomes 4, right? 4 is still true, so we can still go on. 5. So we add 5, 9 with 5. Right? The sum becomes 40. The counter becomes 5. Right? The 5 is still less than 6. Right? It's still true. We go to fetch, we go to 6, n becomes 6. Right? Finally, we get 20. Okay, pay attention. For the last step, counter is now become 6. Here, pay attention. Counter becomes 6 by this one. And we test this again. 6 is less than 6. This is false, okay? This condition is not satisfied. So we go to this path. This part will not be executed, okay? So this is false. Then we finish. We output sum here. Output 20. You understand? The whole process. We call this loop. Okay. This loop is counter-controlled. So how can we implement this flowchart as C programming? The counter increased by 1 every time. And for this question, we just only use 3 variables: counter, sum, and n. So this is more space efficient, okay? Although we get the same result, but this loop structure makes your code more space efficient. But how can we implement this structure using C programming? We use for statement. Condition is tested first. Loop is controlled by counter. Okay. The for statement is like this. We have said that you should analyze the problem and you should know what is your initialization, what is your condition, and how to update the counter, and what is your repeating behavior. If you have more than one statement to execute, you use block to contain them as a whole, okay? If you have more than one statement to execute, you use this one. So, initialization, condition, update. Three element. are the three key elements to write false statements. Okay, this is your homework. I ask you guys. It's your homework now. Convert the flowcharts by C programming. False statements. Okay? Okay, you can leave now. You understand the homework?
Yes, teacher. I
Okay,
understand.
good. Okay, good.
No, teacher.
You can finish, you can leave now.